Thank you very much. Let me introduce a little bit in a couple of sentences the company and then go forward with the evening. We are here called now McKinsey Digital Studio Budapest, and we are working in the digital building business, not just on the engineering side or like creating software and stuff. We are building the ventures themselves too. So coming from this, we are a mix of people, including both business consultants and engineers together, working on these awesome projects. Actually, we can talk a little bit more about this life after the break. This is where my travel experience came from. 2.5 years, almost every week. And only the Corona stopped it at that point. And my name is Sándor, and I'm working here for more than 5 years now as a tech lead and architect, leading teams throughout Asia and Europe, introducing microservice architectures into mostly financial institutions, but we had different industries experiences together with our partners. And that's about it from my side so far. And first of all, a question toward all of you, and please try to estimate. What do you think? What was the largest Guinness record orchestra? How many musicians played in that? 5,000. 5,000. Any more estimates?
5,001.
5,001 for one, second, third. It's actually 12,000. Last year in Venezuela, in the organization of the military academy, there was 12,000 musicians playing Tchaikovsky for 12 minutes. And this was the official Guinness record. So but why I'm talking about this actually? Tonight we are talking about the orchestration and choreography and which one is the better to choose for our solutions. So why the orchestra? In the evening we will go through the orchestration and choreography for the positive side, challenges, and which situation we use. Please hold your questions until the end of the presentation, and there will be a dedicated Q&A section for that at the end. So, and for the orchestration, it's would you imagine if there was no leader in an orchestra, how would it sound like? Very much, but maybe from the point of view as a listener, it would be kind of muddy. Because the individual musicians just only hear from their point of view the entire piece, and as there are large, usually hundreds of people are playing in an orchestra, they are super hard to understand. For example, a drum is too soft, the flute is out of key, or the violin is too loud. So they have a central person, a conductor, in front of them to direct the small instructions to all of them. And this exact same situation is in the orchestration pattern, but first let's set the stage for it. And in the banking business, just imagine a usual daily banking application you use, just sending for the transaction every day. These processes are always well defined in a bank. Very rarely a new bank just grows out of the bunch next to you. So they tend to have decades-old established processes for moving money from one account to another. And these well-established processes are already implemented in their systems. How to reuse them? Imagine just a basic transaction. What happens? Your account gets credited, the another account gets debited, and in the meantime the bank records the audit log for later purposes for the regulatory checks. These are well situated, ordered steps. And that's what exactly an orchestrator is doing, sequentially calling each of the reusable components under it. This has some really good advantages, the business logic you can see clearly in a single point. and you can reason about it. Our mind is already easily understanding sequential stuff, like you are buying from the shopping list in a market, or just following a recipe during cooking. And in the second positive side is that if there is something going wrong, it's easy to point out, easy to reason about the conditions and where some failure actually happened. Although, imagine that the same mobile application, now 1 million users uses it. We still have a single point which controls, for example, the transaction. If there is an issue with that that component, then everybody, all the 1 million users, is affected by it, and the entire process is affected by that problem. These strongly coupled workflows steps are then super hard to scale too. Imagine a more complicated situation where, for example, in an onboarding process, we are creating a PDF file in the middle of it as a contract. That's a more expensive operation than probably the other 70% of the code inside the same orchestrator. And for this, I need to scale it up for the 1 million people. Now I'm actually starting to waste a bit of infrastructure because I'm scaling code that won't be used so much, as the PDF generation is actually holding up the bottleneck in the middle. And later on, there is one more contract I have to include because regulatory requirements are changing all the time. There is one more tax supporting document to be written in the same onboarding process. Okay, I just put it into the same orchestrator, fine, let's move on. And then half a year later, after like 12 or 15 more features, now you kind of tend to have a monolith itself, because now it became so complicated. With this, we are increasing the number of dependencies too, which increasing the complexity of testing the same component. Because now more components to be mocked out, more moving parts, and now I'm in responsibility to communicate to all of the components, etc. So there are some couple of challenges here. But now let's see an example in action.
Okay. In this example, we'll go through a digital signature and its process. Usually, external provider is dealing with the digital signature process itself, and it is exposing endpoints, and it is driving the whole process. In this example, we have an external digital signature service that is the external provider, and the digital signature service that is our implementation. And when the user starts the signature itself, our component will go through the 3 steps the external provider is requiring. First, we have to initialize the digital signature, then we have to upload our documents, and at the very end we have to sign them. These three steps only make sense together. There's really no need to do them asynchronously. Therefore, we can actually wait for them. And at the very end, when we get an OK sign back, we can let the user know that the digital signature was a success, and he or she signed the documents.
You usually even have to solve it like this, because you cannot sign a document until you uploaded it, and etc. So these are the added complexities of older systems to be interacted with. And now let's imagine a dancing group and try to apply the previous solution. You look at the conductor of like what to do at the exact moment. Would look a little bit weird and would be super hard for all the dancers to look for a fixed point throughout all their movings. But okay, what kind of other solutions could we use to keep these independent actors in a beautiful movement of patterns together? Like music. Exactly. They are practicing way before. Actually, with the music, they are synchronized together, each of them doing their own personal thing. on the event stream actually, what kind of, would be the music notes actually in this regard. Now, but let's set the stage in a business sense. Imagine your basic everyday personal loan that you could spend for anything. That's an unsecured cash loan, unsecured because it doesn't back by anything else to be actually material. These usually have more than a dozen systems to work together until as a user you get the final contract of like, this is how you pay back this is how much money you get, this is how you pay back and for what kind of interest rate. Before that, there are dozens of systems working together, for example, FICO scores, risk analyses, different systems like blacklist and other sources are collecting the information, even if possible, your income and already available leverage information. Some countries can do it in Europe actually, of course with your permission, but these systems are highly independent from each other. And in the cash loan, actually only the end result matters. Like you need to have all of the information and correctly secured risk analysis behind it as a bank. So you can kind of play around with the components freely. Like you can move them before, after, so even making it a better user experience. Not really asking for so much information if you can already collect them, or later you can collect based on some smaller info, like only your ID card info. You could collect half of the information that's needed for a cash loan. In this regard, we have the choreography pattern, where now independent components without the conductor in the middle can communicate this between each other. And still with somewhat targeted events, they are kind of calling of like, okay, I already uploaded my ID card information and somebody else reacts to it to collect whatever it can based on that. Now, the complex flow is actually distributed into multiple components and their events systems. They're entirely parallel, like there are no waits happening in this system. This can go through as fast as possible, like the slowest item in the system is scaled up, then the entire system actually benefits from it. And you can only, scale up the slowest component without scaling up all the other components that are actually not that much used. This spares with the infra cost in the long run actually. And although in the previous solution you can reuse the components, but they are a bit more tightly coupled to each other. Here it's, well, you have a larger freedom to reuse the components because they don't really rely on what the source is actually sending them. But even we can take it one step further to the extreme level, where we don't even have targeted events. Now we just only have a new state event. Like this was the previous state, this is the new state, and I said to everyone. Like then the source does not care at this point of like who gets it, what kind of events happens. You can imagine like customer object updated, and there are some new parameters in it. Every single microservice that are interested in the customer just gets the new event and reacts to it. Now we pushed some responsibilities into these components, but now we ended up very loosely coupled microservices that are super easy to reuse in different purposes. Here, each service decides on their own what it gets with the data. It decides if like I don't have enough information in it, like for example the risk engine is easy to decide, like I don't have all of the income information, so I don't have to do anything with this. Or I have now enough information, I do my job, and I go back, this is the new state I want to save to the application. Although this has its unique challenges. Now, we don't have the central component where we could see the business logic easily. Now the business logic is just the side effect of the events happening in all of the components all out the system. Now this leads to a hard monitoring of the system, like very hard to follow through a request throughout multiple, even like sometimes dozens of microservices and through events and different technology stacks. So it requires extra work. At the end, not all of the states actually makes business sense. So like there is a bit of noise in the analytics, like sub-states are actually happening on the logs, which doesn't even care about, the business doesn't even care about. It doesn't make sense of like if an email or SMS sent out, but it cares about that the one-time password sent out, which is like now in 3 or 4 events. And that is another extra problem, especially with the extreme version of the choreography, is that the microservices can be re-triggered in the same state. Because another microservice is working, changing the state, and the second microservice gets now twice the exact same state that he can work on. This needs to be countered by idempotency and other solutions to make the system actually swallow those waves of events. And it's actually wasting a little bit of calculation time for all of the microservices that are participating in it. Now let's see a choreography in action.
Okay. In this example, we'll go through the risk calculation. When a bank lends the money or an insurance company gives insurance, they measure the risk of the action. In this case, our risk engine is responsible for the calculation, and we also have 2 other components, the BFF that will drive the whole process, and it will get triggered by the user, and the notification service that will send out notifications like SMS or emails. And we also have 2 communication channels. One is the loan application changed channel. This is a channel where the BFF will let the risk engine and the notification know that a loan application happened. And we also have the risk scored channel. That is the channel where the risk engine will send out the calculated risk. The user sends the action, and the BFF publishes that a loan application happened. I'm not sure if you can see from the very back that the arrow is actually blue, meaning that the event is originated from the BFF. The risk engine and the notification service receives the notification. The notification sends out the emails, the risk engine calculates the risk, and the risk engine publishes the results. And the BFF consumes it. Here we can take the extreme way and take a step further. This publish arrow is actually purple, just as the risk engine, meaning that a service can send out 2 events. The risk engine actually sent out 2 events. One that it received from the BFF, originated from the BFF, and it sent out another, originated from the risk engine. If we go back a little here, the risk engine could actually send out 2 events. The BFF therefore received an event originated from the BFF and one originated from the risk engine. This is a wave. However, if a microservice would send out all notifications it receives and an extra one originated from itself, the loop would never end and we would drown in the wave. Therefore, we need a condition to stop it. In this case, the BFF stops the event it started. Therefore, if it sees that the event is originated from the BFF, it stops the streaming and only publishes the reaction to the risk engine's event. The risk engine and the notification receives the event again, originated from the risk engine. The notification sends out the actions again, and the risk engine stops the publish since it was the originator.
This is the part when the idempotency is really important to not have like 2 SMS sent out for the same reason. But now, how to choose between the 2 systems, the 2 solutions? Only us it thinks in absolutes, but we are engineers, programmers, coders, whatever. Our job is to use the correct tool for the correct problem. So the orchestration is the total control on one side, and the choreography is a controlled chaos on the other side. Could we get the best of the both worlds? Actually, yes, we could get with a hybrid approach. So whenever you have independent processes in the system, and as a baseline try to find these independent processes, use the choreography approach, and whenever only the sequence only makes sense in order, then use the orchestrator part, but as sparingly as possibly. And now put together the two idea of like an opera or any symphony where both dancers and orchestra plays. Then the orchestra plays the music where the dancers are being choreographed on. Just as putting together the two example, let's see it in action.
Yeah. Basically, in this example, all previous ideas appear. We have a risk engine that is responsible for the risk calculation, the notification service, and also the digital signature service. The BFF receives the user action, and all three components receive the notification that they have to start their work. And the risk engine publishes the calculation, the notification, and actually sends out the emails. And the digital signature service in separation can start the sequence that is required to sign digital signature. And separately, the service can do it. And in the background, the whole asynchronous flow can continue. And one addition, that all these examples are actually coded in JavaScript. I'm not sure how can we
But we will definitely
them,
distribute and publish them after the event with the presentation together. Yeah. I think
that's all.
That's all. Thanks for the attention, and now you can have a couple of questions.